Okay, today we're going to take a look at the Pythagorean theorem and its converse, which is 10.1 and 10.2 in the book. Good examples in there for you guys to look over as well. Trying to do this video lesson to give you a few examples to work off of as you attack those. So hopefully this will be something we can use that will help you get through Thursday's lesson with some nice easy afternoon. Here's the kind of the basics of the Pythagorean theorem. Generally, whenever I talk about this in a class of geometry students, you guys have seen it or heard it before. When I say Pythagorean theorem, most of you think a squared plus b squared equals c squared, which is true. This is where it came from in the beginning a little bit. We need some terminology. Remember, we're only allowed to use Pythagorean theorem in right triangles. It's not going to work in every triangle, but it'll work in every right triangle. Always identify where your right angle is. The two pieces that are making that up are going to be your legs, and then the one opposite of the 90-degree angle will always be your hypotenuse. This is a relationship that was discovered a long time ago. I always claim to people that it was probably somebody when they were measuring land plots and they had the two sides and they made the guy walk off this distance over here. He probably was looking for a shortcut to figure out how to do that a little bit easier, and maybe that's the guy that we're looking for that came up with Pythagorean theorem. So here's kind of where the developing of this was, where it came from on the next page here. When you look at this, I have a right triangle with sides of 3, 4, and 5. Okay? And what they did, and you can look at this same type of diagram in your book, they took and built a square off of each side, okay, as well as we could here. And so if we're talking about being a square, then if this side is 3, then we have a 3 up here. Okay? And if this side is 4 down here, then we'd have a 4 here. And if the hypotenuse is 5, then we'd have a 5 here. So they started looking in any right triangle at what happens with those relationships. And they did some different figures and looked at how they were related. And with this one, what they came up with is if you look at the two legs, and the area of this square would then be 9, 3 times 3. The area of this square would be 16. Okay, and then the area of the one off the hypotenuse would be 25. You know, hopefully at some point in your math career you've seen this exact same description or kind of presentation on how this was. So when you look at that, if you have a right triangle, you're always going to have the same thing happen for you. The area of the two squares that are off of the legs is going to equal what you have off of your hypotenuse. So when it was first written up, the Pythagorean theorem was leg squared plus leg squared equals hypotenuse squared. As it's been shortened through time to what people understand, we've started to use a squared plus b squared equals c squared. That's how you guys see it on pause testing, maps testing. Whenever you see that formula, that's the one that you get, that you're going to see. Remember, a and b have to be your legs, and c always is your hypotenuse. One quick note, your hypotenuse always has to be your longest side, which whenever we talk about that, you guys are pretty solid there, so I think we have that. Looking at the next slide, a couple of examples. I'm going to do 2 of these and then we can go from there. You guys can take care of the third one over here that you're seeing. Find the missing parts. When I talk about this, the main thing that I want to make sure is what are we after? Are we after a leg or the hypotenuse? Because we need to make sure we're putting things in the right spot. In this first triangle here, when I'm after P, that's one of my legs. Okay, the other leg would be the 12, and then of course the 13 would be my hypotenuse. I'll put an H by that. So when I go to set this up, you're talking about having the leg squared, so P squared, plus the other leg, 12 squared, equals the hypotenuse, which is 13. 13 squared. Okay? As you work through that, you're going to have P squared plus 12 squared is 144 equals 169. By solving that, we move the 144 over, minus 144, as well as I can on here. And I have p squared equals 25. How do we undo something that's squared in algebra? Opposite operation means that we have to take the square root. So we're going to take the square root of both sides here. You guys know square root of 25, we're going to wind up with 5. So in this case, p equals 5. Sorry about that. Every once in a while this pen gets bumped and I wind up on page 3. So p equals 5. You would know, always logical answer here. If I get an answer that, if I'm looking at this triangle and I get an answer that's greater than 12, certainly if I get an answer greater than 13, we've got some problems. But 5 definitely makes sense there. So that's fine. Those aren't always going to be perfect squares. You could certainly wind up with the square root of 31, something that didn't come out even. We can just leave that for right now. That would be fine. Okay? So that's an example where you're talking about finding a leg. If we look at the next one, and we're talking about this picture, here we're after the hypotenuse, okay, because there's my right angle. Opposite of that, these two guys, obviously you'd have a leg here, written as well as I can. You'd have a leg here, okay, and then this would be your hypotenuse. So when I set this one up, it's going to be leg squared plus leg squared equals hypotenuse squared, which, as you once it's set up, you're good with the math part. We have 64 plus 225 equals m squared. That's 289 equals m squared. And same story, when we have to undo something squared, we're going to take the square root. So we have 17 equals m. Okay. Again, hypotenuse, if I have legs of 8 and 15, my hypotenuse should be greater than both of those. Okay? So that's another example of using the Pythagorean theorem to find a part there. On the third one, just really quickly here, when you work through this one and you get x, it is going to be, you are going to wind up with a radical number there. You can give me the radical or the decimal. I can live with either one right now until we do some work in 10.4. On the other side of this, 10.2, all of your problems from 10.1 are just that. You're talking about a triangle, you're going to identify the parts, and you're just finding the missing piece. So, same thing, is it a leg or hypotenuse, and work your way through that Pythagorean theorem. On the flip side of that is 10.2, which is the converse of the Pythagorean theorem. You're seeing that here. Really, when you look at this, what it boils down to is, can we determine if a triangle is right using what we know from the Pythagorean theorem? And honestly, as you're looking at this page, it comes down to right here. If you are going to say that a triangle is a right triangle, the only thing that has to happen is the sides have to work in the Pythagorean theorem. Whether it looks like one or not doesn't mean anything. You may say, well, that kind of looks like a right angle. That doesn't mean anything mathematically. We have to have a reason why it works. So in this one, as you're looking at it, of course your hypotenuse has to be the longest side. So when I go to set up this first one, if I'm going to check this, is this a right triangle, I would have legs of 8 and 5 and a hypotenuse of 9. So when I go to set that up, I would have 5 squared plus 8 squared equals 9 squared. And as I work through that, I would have 25 plus 64 equals 81. When I wind up with that, I get 89 equals 81, which is not true. So in this first example, that is not a right triangle. Okay? The second one, as I look at this, if I try these sides, 7, 24, and 25, you're going to have a better situation. This 25 would be your hypotenuse. Those guys would be your legs. You're going to set up 7 squared plus 24 squared equals 25 squared. So you're going to wind up with 49 plus 576 equals 625. When we do that, we get 625 equals 625, okay, which is true. Since the sides worked in the Pythagorean theorem, yes, it is right. Okay, so at that point, I would know that this was a right angle right here between my two legs. In the first example, this is not a right angle because it did not work in the Pythagorean theorem. That's a wrap-up of 10.1 and 10.2. In 10.1, I'm asking you to do 1 through 3, 5 through 7, 9, 10, 13, and 15. And in 10.2, I'm asking you to do 2 through 5, 7, 8, 11, 12, and 15. They're pretty short problems. You need to make sure you show your work. And if your radicals work, go ahead and give me the number. If it doesn't work to be a perfect square, then go ahead and leave it in radical form or give me a decimal to 2 places at this point. Hope you have a good week, and we will see you on Monday.